Hello, welcome. What am I? Who am I? Yes, let's start with that. So I work at a company called Weaveworks. I am a software engineer. We run a system, a SAAS system. We've been running it on Kubernetes in production for 2 years, more than 2 years. But my personal thing is making things go faster. Optimization is like a video game to me because you can do it for hours and hours and hours, and there's a score. And in that sense, so that's what I'm going to talk about. I'm going to talk about a couple of CNCF projects, Prometheus and Jaeger. I'm going to talk mostly about some kind of war stories from my life at work. But maybe some of that information is useful to you in your work. So that's the idea. Is anyone in the wrong room? No? Okay, let's get started. Okay, so who already knows Jaeger? Half, maybe a third. Okay, good. Who already knows Prometheus? Most people. Cool, good. And anyone already heard of my company? Oh, quite a few. Great. Nice to have you here. So this is where the story starts. I was sat there looking at this on the screen, and I got bored, and what I wanted to see was this, is dashboard. This is the kind of stuff we do with our Weave Cloud product. I wanted this to appear, and it was too slow. So that's the beginning of the story. The back end of that thing is an open source project called Weave Cortex. It is a multi-tenant Prometheus because we run all the storage and back-end servers and everything. If you want to use that, you can sign up. And so this is just to indicate it's kind of a bit more complicated than that in real life, but there's multiple parts to it. It's a distributed system, so it's quite a complicated beast to optimize. What are the 3 most important things in software optimization? I hear you ask. I like to put this in. I think it's really important to get some kind of ground rules. So number 1, measure. You must measure before you act. Don't just start changing things because you think it's going to make it go faster. Measure first. The next most important thing is measure. Measure the real system. Don't measure some tiny benchmark or a blog post, or measure the real system really doing what it's doing. And once you have measured it, then keep on measuring it, because you need to know how it behaves after you've changed it. You need to know how it behaves over time under different loads. So measure is one of my key messages for optimization. Let's talk about measuring a distributed system. This is where we're kind of getting back to the projects I'm going to talk about. So any system which has multiple parts, basically what we're going to need to do is get the information out of all of them, or as many as are involved in whatever requests I'm interested in, and we're going to want to collect that information in some central place. So that's the basic pattern. Prometheus, most of you put your hands up, so I'll just briefly explain. It is a time series metrics system. So time series meaning a quantity that varies over time. And you might be measuring CPU utilization or memory usage or things like that. Prometheus project ships a bunch of exporters, which are things that gather the raw data and send them out as metrics. And but you should definitely also have metrics from inside your services. And we we talk about the RED methodology: request rate, error rate, and delay, or we usually call it latency, but it makes a crap mnemonic. So we went with delay. So just go back to that picture. In the Prometheus case, the Prometheus server sits there, and it requests the metrics from all those exporters and from all the parts of your system, and it collects them on the central place, and you can query it. Jaeger has a much nicer mascot, and that's important in my choice of software. So Jaeger is very much, what is my system really doing? What is it doing in much more detail? What is it doing as the flow of control moves from one part of the code to another, as it moves from one component, one microservice to another? That's what Jaeger is all about. And again, we're going to want to collect all of that information from all the different parts and bring it together so we can look at it. So that's a brief introduction. We'll get into the war stories, and you'll see those things in use. So my first war story is entitled "The Case of the Mysterious User Service Latency." So what is this about? Well, let me start from what was I as the operator of the system. We don't have a separate ops team. The engineering team runs very lazy as engineers, and so we tend to automate everything. So we have a bunch of machinery running, measuring things, and alerting when things go wrong, and so on. So this is a typical dashboard that we might be looking at, and we look at would be slower than this time. So take the 99th percentile, the median, the 50th percentile, and the mean. Those are three measures that you can compute. Well, the first two anyway, with a Prometheus feature called a histogram, which is very powerful. And that's a very typical kind of SRE in today's terminology. Metrics to look at, because it gives you an idea. In this case, the mean and the median are relatively so short, so quick, that they don't really show up above the zero line on the chart. But the And in the Prometheus syntax, you tell it what you want to summarize by. So next thing I did was I dug in. Well, let me just draw your attention to the fact that some of this is showing a chart over a couple of days, and some of the time it's running at 4 seconds, and some of the time it's running at like half a second. So so you might want to think, what's happening, what's the difference between those times, who knows. When I drilled in, I added this extra parameter to the query, route. I can say route because I'm in Europe. In America, I have to say route, and it gets me confused because I can't translate all that quickly. Anyway, drill in, so route is like where are we sending the request internally, and it becomes a very different picture. It actually says that one request in particular is actually pretty steady at 5 seconds. And the rest of them are kind of flapping about. So this is an illustration of how averages can confuse or misdirect. Because we were taking the average of everything, 1 in 100 was sometimes at a certain level and sometimes at another level. And in fact, those differences were driven by how many other requests were in the mix. Because we're averaging them. So definitely a tip there, beware of averages because they may be hiding something important. But Prometheus, fantastically powerful, just a slight edit to that query, we can drill in, we can find out what that is. And it turned out it was a particular request that was hitting the database. So I didn't have detailed information on how we were hitting the database, so I needed to get some detail on that. I decided to use Jaeger. How does that look? I'm not going to go through that in detail, but basically it's like 3-4 lines to kick the thing off. At the beginning, this goes in your sort of main program. And then one more line to bring in a library to instrument my SQL calls. So there's a few libraries out there. I happen to pick this one called Expansive Worlds. Don't write it down until I get to the end of the story. No, it's good. It's good. So now I've got tracing. So what does that look like? I mean, let's tempt the demo gods. There was that dashboard earlier. This is the Jaeger dude. So you put in some kind of, this is the Jaeger screen, you put in some kind of thing that you want to look at. Okay. And Jaeger goes and finds all the information it's got on what's been running, and it's a little kind of histogram. Some things are slower than other things. And you click on one of those, you drill in. So let's go back to my slides. Let's not tempt the demo gods anymore. So what I could look at now is this kind of display. Let me just walk through this. For those of you, about 2/3 of you did not raise your hands about when I asked if you'd used Jaeger, so I'm going to tell you what it all looks like. Down here on the left, we've got the kind of the call stack. This thing calls this thing, calls this thing. And you know, this is the details of our user authorization service. So you don't need to know anything about that. The point is, because I added that SQL tracing, I can actually now see the SQL query that's being executed, whatever arguments, anything like that. And at each point, I get the what's called the span, the time span, the beginning and the end of each operation. So I can see that in however much detail I've instrumented my code, and that works across component. So we just trace everything, and we get all that detail out. Is that okay? Is that clear enough there? Yeah, good. Okay. It turns out that wasn't enough information to find the problem. Sometimes life isn't like that. It turns out the actual problem, which I just sort of figured out while thinking about what could possibly be going wrong. In this particular case, the problem was that we had accidentally disabled connection pooling to the database, and that the Go SQL library doesn't have a hook to find out when it's opening a new connection in the connection pool. So we were not getting that traced, so we were not getting it in the detail. Can't help that. I did fix it. Again, when I went back to my chart, because I have all the data from whenever that was, December, this big average, the 99th percentile, it sort of flattened out. It got less spiky, but it's not that impressive. So I'm showing you the median instead. which came down from, I don't know, 22 milliseconds to 4 or something like that. So that's that story. You know, it doesn't entirely have that neat narrative that I could just point at the answer, but it was very good at eliminating a lot of other possible concerns. For instance, I could see that the actual SQL queries were pretty fast in every case, and I had to go hunting around trying to figure out what else could possibly be causing my problem. So that's war story number one. Okay, let's go back. Remember this? This was at the beginning of my talk. So I had this on the screen, and I wanted it to show me a dashboard, and I had all the tracing. So this is actually this is the screen grab I pasted into the GitHub issue. So this is the actual evidence that I had on hand at the time for those slow queries. And again, the pattern is that it goes down through the hierarchy of calls, and it's doing a bunch of different things. This is inside Weave Cortex, which is the multi-tenant Prometheus that I mentioned. So I want to draw your attention to a couple of things that I could see on this screen. So zoom them in. First thing is that little exclamation mark there, that says that this operation errored. So my cache call was erroring. And this was a very large part of why it was too slow. So that was immediately, that's the big picture. It's immediately clear, just one of those operations errored, and that was really important. And the other thing, I just zoomed in that bitmap. The other thing is this long diagonal line. Long diagonal lines to someone like me that's been optimizing and using these kind of tools for, I don't know, a decade. That says serialization. That says those things are being executed one after the other. And it says to me as an engineer, why don't you parallelize it? Can these things be executed in parallel? Well, yes, they can. So this is the trace from a couple of weeks ago. All of those operations start in parallel. The whole thing is horizontally scalable. They all execute in parallel. They all finish enormously faster. So there you go. There were two very important things in that one screen grab of Jaeger that was showing me. So that's my war stories. I just want to kind of distill that down into what I call the patterns to look for, and made a list of them. Hopefully some help to you if you're thinking about using this technology. I made a list, and then I thought, well, I've got one at the very beginning. I'll call this pattern 0. So this is the very most obvious thing. If you've got a bunch of these spans in a tool like Jaeger, look at the longest one. So like I don't want to get complicated. That's where you're going to get the biggest bang for the buck if you look for the longest one. And then actually it's on this picture. When I was doing the slides, I thought, oh, actually there's another kind of lesson hiding in there, which is this whole region. What happens is that it shows you this bit kind of zoomed in and this bit zoomed out. This whole region over here doesn't have any detail in it. So that's my second pattern 0. If you don't have any detail, you need to go back to the code and add some detail because you have no idea what it's doing in that gap. And that is, it's an iterative process, right? You speed up one bit, and then that makes another bit the most important thing, and then you go around the loop. So yeah, we need some detail in that gap. Next one, that long diagonal line that I spoke about. Sometimes you're running an algorithm where one step depends on the step before, in which case you can't just parallelize it. But in most cases, you can parallelize it. There's a whole scientific computing world of people who've been doing this for many decades, and rearranging the work and so forth so that it can be done in parallel and summarized at the end. So yeah, very much a trigger for me to go look at parallelization, that long diagonal line. Another interesting one, if I see a bunch of things exactly the same length, I think, why? Why are they exactly the same length? Like, everything in a concurrent dynamic system, everything's a little bit random. Everything's running at once, everything's contending for resource, things kick off at different times. Why am I seeing these things take exactly the same time? So I would, the one that actually triggered this in my mind was a timeout. In fact, the work was just being curtailed at a particular time, and everything was being thrown away. But it could be some other reason. But I mean, that's kind of suspicious. Like a bunch of spans all exactly the same length. Think about that. And then a kind of a variant of that one is when they're all different lengths, random. That's what we'd expect. They're all starting at different times. That's random. That's what we'd expect. But for some reason, they all finish at the same time. And again, as someone who's been looking into these problems for a long time, this is a trigger to think about some kind of interlock. If this is hitting a traditional database, I think there's a transaction holding up the long one, or some kind of multi-thread lock, or some kind of resource that they're all contending on, or something like that. So what happened at exactly that time that meant that all these things were waiting for it to happen? And can we get rid of that wait? Because that's one of the things about these spans, is they don't necessarily tell you whether the thing was busy all that time. It took that long, but maybe it was just waiting on someone else to do something. So yeah, that's another interesting one too. So okay, that's my tracing patterns. Summarize, measure, measure, measure. That's my big lesson. Prometheus and Jaeger are great tools. I gave a kind of whistle-stop tour. I guess we'll have time for questions in a minute. So if you want to know any more detail about how we use that, look for those patterns, which give you a real insight into what's going on. Or just pay someone like me to run a hosted service, because that's what we do for a living. Thank you.